for this problem, we have the following circuit, and through repeated applications of Norton's theorem, we need to find the value of the short circuit output current for the circuit shown in milliamps. We're also given some values right here. So to start this off, we have to notice that we are going to look at the short circuit output for the current. So that means we're going to look at these two terminals, A and B, and we are going to short circuit it like this. More information can be found in the notes that are in the notes. Engineering 17 notes linked with a like button. It's in page 35, and we have some more information about short circuiting the terminals. But for now, we're just going to look at this, and the voltage across a short circuit like this is going to be 0. We have 0 volts here. And since this resistor is in parallel with this voltage, well, we know that voltage across two things in parallel is going to be the same. So the voltage across here is equal to 0. And so we're not going to even bother looking at this resistor. Now, there's two different ways we could do this. If we wanted to, we can convert this to the Thevenin's equivalent, and then combine these two resistors, convert it back, combine these resistors, and we have our current. Or what we can do is look at the node right here, and we'll call this V. And so we know that with the node voltage theorem, or method, we have some current going in this way, and we have some current going out this way, and some current going this way. And so with that in mind, we can write an equation for this. We have a negative I for the current going into our node, plus the V over our R2, plus the V minus the voltage right here, because when we're looking at the voltage over, or the current over this resistor, we take the source voltage minus the output voltage, and then this is all happening over our resistor 3, set equal to 0. Now we can minimize this a little bit, and if we are to do that, we are going to get the following. Our equation looks like this once we plug our values in. I also substituted the V's for X's. And so our V is going to be 50.43 approximately. And so now we know the voltage right here. With the voltage right here and our resistor right here, it looks more like the Thevenin's equivalent, and we want the Nortons. So what we can do is we are going to move the resistor, and we still have our terminals A and B. We're going to remove our R3 to be like this. And if we do that, well, instead of having the voltage right here, we have to find the current there. So the current is going to look like this. And now let's find the current. Well, the formula to find the current is as follows. We use Ohm's law, where I is equal to voltage over resistance. We know our voltage is 50.43 and our resistance is 7 kilo ohms. And so we can plug this into a calculator, and we're going to get approximately 0.0072. Now, we all want the answer in milliamps, not amps, so we just move the decimal 3 to the right. And that means the answer for this problem is going to be 7.2 milliamps.